These are the notes for lesson 7-5, day 2. We are going to be using the properties of logarithms to solve equations. These are the same 3 properties of yesterday, so I have rewritten them for you. And once I move the screen, you can pause the video to rewrite them down, or not, whichever you prefer. There they are, the 3 properties. Okay, so we are going to use these properties to solve some equations. And the equations start out fairly linear, and then they go to slightly quadratic type things. So number 1. Again, we're using our 3 properties to solve the problems. Log base 6 of x minus log base 6 of 2 equals log base 6 of 12. So the right-hand side is just one logarithm with a number. So we're going to ignore it for a moment. Look at the left. Of your 3 properties, which one does this match? Is it a product, a quotient, or a power? Subtraction is the quotient property. So we're going to rewrite this as log base 6 of the quotient x over 2. And now, just like when we were solving exponential equations quite a while ago, the things that had the same base, in this case the logarithms that had the same base, cancel. So both the log base 6's go away. And we are left with the fraction x over 2 equals 12. You know how to solve for that x. To get rid of it divided by 2, you multiply by 2. So x equals 24. All right, let's try it again. Number 2. 4 log base 2 of x minus log base 2 of 5 equals log base 2 of 125. So I shall tell you, you always do the power property first if you can. So can you use the power property here? Yes. This number in the front, this 4, becomes an exponent within its logarithm. So it becomes a 4 power on the x. So what we really have is log base 2 of x to the 4th minus log base 2 of 5 equals log base 2 of 125. From here, do you know what property to use? Hopefully you decided to use the quotient property. So this becomes log base 2 of x to the 4th over 5. The log base 2's will cancel. X to the 4th over 5 equals 125. Multiply by 5. X to the 4th equals 625. And hopefully you know that that is 5. You could take the 4th root on your calculator if you don't know that. There was a second way to do this problem, and some of you probably did it. So if you back up to this step, I know a lot of you like to get x by itself right away, and this is awesome. So you could have, at that step, added over the log base 2 of 5. So you could have log base 2 of x to the 4th equals log base 2 125 plus log base 2 5. In your case, you would change this into a product instead. So log base 2 x to the 4th, log base 2 125 times 5, 625. The log base 2's still cancel, and you still get the same final answer of 5. So if you did it that way, very good as well. All right, number 3. I would like you to try this one on your own. Log base 3 of n equals 2/3 log base 3 of 8. Pause it. There's only one property that you can use. Use it. Do the problem. Welcome back. Hopefully you decided that 2/3 was an exponent. And so you'd put it up here with this 8. And write it as log base 3 of n equals log base 3 of 8 to the 2/3. And the log base 3's cancel. So 8 to the 2/3. There are a variety of ways to get from 8 to the 2/3 to the correct answer. You could use your calculator. It might tell it to you. You could rewrite 8. 8 is 2 times 4. 4 is 2 times 2. So this is 2 to the 3rd to the 2/3. Powers of powers mean that you multiply. 6/3 is just 2, which gives you 4. You could remember that 2/3 can be written as a root. And in that case, you would go divide by 3 means a cube root. So we're looking for the cube root of 8 squared. And the cube root of 8 is, of course, 2. So 2 squared is still 4. All right, number 4. Number 4 is going to give you a quadratic. So log base 8 of n minus 3 plus log base 8 n plus 4 equals 1. Addition tells you to multiply. And what are you multiplying together? 2 binomials. And how do you do that? You distribute correctly, which we usually call FOIL. So this is log base 8 of the quantity n minus 3 times the quantity n plus 4. We use the product property. So you're going to FOIL, or just distribute correctly. And then after distributing correctly, there is only one thing that you can do to solve this problem. Do you remember what it is? When you have a logarithm on one side and a number on the other, you rewrite it as an exponential. So what is the base? The base is 8. What is the exponent? The exponent is 1. And what does it equal? the argument, the stuff you are taking the logarithm of. And so if we write that down, we will have n squared plus n minus 12, because you can. So it's a quadratic now. We need to solve it. How do you solve quadratics? You make them equal 0 so that you can factor. To make this problem equal 0, we're going to subtract 8. So 0 equals n squared plus n minus 20. Two numbers that multiply to 20, negative 20, add to 1 are positive 5 and negative 4. Solve for n. N could equal negative 5. N could equal 4. Do you remember when we solved for n in the last chapter with logarithms? You have to check your answers. Can n be negative 5 in this problem? Go back all the way up to the top. If you plug negative 5 in, negative 5 minus 3 is negative 8. Can you take the log of negative 8? No, because it's negative. So that means negative 5 does not work. So we can't have negative 5. Can you take the log when you plug in 4? Well, 4 minus 3 is 1. So the first logarithm is safe. And 4 plus 4 is 8. So the second logarithm is safe as well. So 4 works. So our answer is n equals 4. Okay, number 5. Log base 6 of 2x minus 5 plus 1 equals log base 6 of 7x plus 10. So, logarithms on both sides of the problem don't help you if there is also a term that doesn't have a logarithm. So that one's hanging out there and that one's causing a problem. So we need to get our logs together. So we're going to subtract this log to the other side. So now we have 1 on the left. And on the right, we have logarithms being subtracted. That is one of our properties. Subtracting two logarithms is the quotient property. So we are going to change this into a division problem. So it becomes log base 6 of the quotient, 7x plus 10, over 2x minus 5. And now this problem's like the last one. You need to rewrite it as an exponential. Please do so. So the base is 6. The exponent is 1. And it equals the argument, the stuff in parentheses. 7x plus 10 over 2x minus 5. You have a not fraction equal to a fraction. What do? You're going to multiply. Multiply by the thing you're dividing by. Multiply by 2x minus 5 on both sides. On the right, they cancel. On the left, you can distribute. So 12x minus 30 equals 7x plus 10. And you know how to solve that. Did you subtract 7 and add 30? Divide by 5? X should be 8. Again, check your answer. So x equals 8. If you plug 8 into the first logarithm, you get 16 minus 5, 11. It's positive, you're good. If you plug 8 into the second logarithm, you get 56 plus 10, 66. Again, it's positive, so it's good. The answer is x equals 8. There are now two that I want you to do on your own. You're on page 487. And I would like you to do both 4A and 4B. Please pause the video and do them both, and when you are done, return. Welcome back. So, problem 4A. The left-hand side is log base 7x squared. And the right-hand side is log base 7, 27 times 3. So, the log base 7's cancel. X squared equals 81. Therefore, x equals plus or minus 9. But when you go to check your answer, the negative 9 does not work. So it's just x equals 9. Which brings us to 4b. So for problem 4b, your left-hand side is log base 6 of x squared plus 5x. And your right-hand side is just a 2. We rewrite it as an exponential. The base is 6. The exponent is 2. It equals the argument, the stuff in parentheses, x squared plus 5x. It's a quadratic. 6 squared is 36. So we are going to subtract 36 from both sides, because in order to solve a quadratic, it has to equal 0 so that you can factor it or use the quadratic formula. So 0 equals x squared plus 5x minus 36. 0 equals x plus 9, x minus 4. X could equal negative 9. X could equal 4. Check your answers. Does the negative 9 work? No. Does the 4 work? Yes. So our only answer is x equals 4. All right, on page 489, there are some true-false questions. Pause the video and do these 8 problems. If it's false, say why. Welcome back. So, number 51 is false. A correct answer would be log base 8 of x over 3. 52 is true. 53 is false. A correct answer is log base 10 of k to the 19. 54 is true. 55 is also true. 56 is false, as is 57, and 58 is true. So 56 should say log base 4 of 2z, and 57 4 log base 8 of p. You have your homework, so please do it, and have a great day.